Hi everybody, Doug Daniel from the Pilots Online Academy, making superior piloting simple. Welcome to Module 3 of Phase 1, Uses of Lift and Drag, Flight Control Surfaces and Coordinated Turns. Here's what to expect. You will build on what you learned about lift and drag in the previous video. You go through control surfaces so you can make sense of a coordinated turn. Then you go through a turn step by step so you can dazzle your flight instructor on your very first lesson. First, a quick look at control surfaces. Then you'll see exactly how to make a turn and why you do it that way. Cockpit controls move in the direction the pilot wants the airplane to move. Pilots use ailerons to control the airplane's bank. When pilots roll the wheel left, right aileron goes down, left aileron goes up, causing the airplane to roll left. When pilots want the nose to pitch up, they pull back on the wheel and the elevators come up. That pushes the tail down and the nose up. When they want the nose to yaw to the right, they push the right rudder pedal, causing the rudder to extend to the right, forcing the tail to the left and the nose to the right. Notice that all of the control surfaces are on the trailing edge of an aerodynamic structure. That is so they will naturally go into a trail position and not exert any force when the pilot relaxes input. When pilots move the control surface from the trail position, it creates lift and drag. Now let's look at how all of this plays out in the cockpit. A pilot must use the ailerons, rudder, and elevator to turn properly. We'll look at each control. In this diagram, the pilot has rolled the control wheel to the left, applying what you call left aileron. The left aileron is up and the right aileron down in an effort to roll the airplane in the direction of the control wheel's movement. Okay, looking at this picture, you can see the left aileron up and the right aileron down out toward the tips of the wings. But there is an unintended consequence. By increasing the lift on the right wing and lowering it on the left, you have increased the drag on the right wing and lowered it on the left. So the nose starts to swing to the right even though the pilot has not moved the rudder at all. You'll call this adverse yaw. And you can see in this picture that the nose is yawing to the right even though there is a slight beginning of a roll to the left. Since the pilot wanted to turn left, this is a bit disconcerting. No problem. The pilot simply steps on the left rudder pedal just enough to offset the yaw. You see, a pilot uses the wings to turn and the rudder to keep the passengers comfortable. This is the instrument that a pilot uses to know how hard to push on the rudder pedal. It is two instruments in one. A pilot uses the little glass tube with a black ball called the turn coordinator. As long as the pilot keeps the ball between the two black lines, the passengers will be comfortable and the airplane will fly efficiently. Now that you know what to do with the rudder pedals, let's look at the elevator control and turn. As the angle of bank increases, pilots have to demand more lift from the wing to keep from losing altitude. Here the pilot increases lift by 15%, so the wing could still pull vertically against gravity with a force equal to the weight of the airplane. But notice that the airplane is accelerating laterally at almost 60% of the force of gravity. Now let's look at what it takes to turn an airplane and do it well. Bank in the direction of the turn. The greater the bank, the harder you pull back on the control wheel. Step on the ball to keep it in the center. This means that if the ball is out of its little cage to the right, apply more right rudder pedal until you center the ball. Keep your bank steady until ready to roll out of the turn. Every aileron movement requires a corresponding rudder movement. As simple as that is, you cannot just memorize your way to making proper turns. In fact, that is a lot of information to learn. The only way to get there is to practice. You need to practice in an airplane or simulator or to practice mentally. I recommend both physical and mental practice. The time you spend visualizing what you're going to do is often more productive than the time you spend in the cockpit. You have learned how control surfaces use lift and drag to influence flight, how the ailerons, rudder, and elevator work and how they interact, how to make a coordinated turn. In the next video, you will learn how a propeller produces thrust, that the weight of an airplane is not always caused by gravity, and why most propeller airplanes want to turn left during takeoff and climb. Thank you very much, and talk later.